Good day, everyone. Welcome to my channel, where I share mental math techniques and shortcuts that can be helpful in taking math classes and examinations. For this video, I am going to share with you 4 ways on how to find the greatest common factor or GCF of 2 or more numbers. If this is your first time on my channel, please take time to subscribe and like this video. You can also drop your comments. So, without further delay, let's begin. In this video, the following 4 methods will be discussed. Listing method, prime factorization, Euclidean algorithm, and an alternative method. Each of these techniques can be used to find the GCF with ease.
Before we discuss their 4 methods, it is important to define some key terms. 1. Factors are numbers that we can multiply together to get another number. 2. Prime factorization, also called complete factorization, of a composite number, is a way of expressing the composite number as a product of its prime factors. So, what is the GCF or greatest common factor? Greatest common factor, or GCF, is the highest number that divides exactly into 2 or more numbers. The greatest common factor is often abbreviated to GCF, and is also known as the greatest common divisor, GCD, or the highest common factor, HCF.
What are the uses of GCF? GCF can be used to reduce or simplify fractions, and in factoring polynomials.
Our first technique in finding the GCF is the listing method. This method simply requires us to list down all possible factors of the given. For example, say we need to find the GCF of 24 and 36. First, we need to list down all possible factors. So for 24, we have 1, 2, 3, 4, 6, 8, 12, and 24. And for 36, we have factors 1, 2, 3, 4, 6, 9, 12, 18, and 36. Then we group or mark the common factors. So here the common factors are 1, 2, 3, 4, 6, and 12. And obviously the greatest or the highest of these common factors is 12. So the GCF of 24 and 36 is 12. Now this technique is very easy and handy for everyone. However, the major setback or drawback of this technique is that when you're given large numbers and you need to list down all possible factors, and in the process you may miss out some common factors or some factors and even the GCF. However, if you are just given with some 2 small numbers, this technique can be very useful. Our second technique is the prime factorization method, and under this method we have 2 sub-methods. These are factor tree method and a division method. So for the factor tree method, we simply list down or break down a given number into its component prime factors, resembling a tree-like diagram. For example, here we need to find the GCF of 30 and 72. First, we factor out 30 into its component prime factors. We have, for 30 we have 6 and 5, and since 5 is already prime, we leave it as is, and we need to factor out 6 into 2 and 3, which are both prime factors. So the prime factorization of 30 is 2 times 3 times 5. Moving on to 72, we decompose 72 into 4 and 18, and for 4 we factor it out into 2 and 2, which are both prime factors, and for 18 we have 3 and 6, and since 3 is already prime, we leave it as is, and then we factor out 6 into 2 and 3. So the prime factorization of 72 is 2 times 2 times 2 times 3 times 3. And then we list all these prime factors of each number, and our last step is to identify the common factors, and in this case the common prime factors are 2 and 3. Now multiplying 2 and 3 we get 6, therefore the GCF of 30 and 72 is 6. The other method under prime factorization is the division method. Now this method requires us to perform successive division, and after that we can either list down or plot our factors or divisors using a Venn diagram. For our example, we need to find the GCF of 36 and 90. Doing successive division of 36, we have 36 divided by 3 is 12, 12 divided by 2 is 6, 6 divided by 3 is 2, and 2 divided by 2 is 1. Notice here that all our divisors are prime numbers. Now these divisors can be translated later on to factors. For 90, we divide 90 by 3 and we get 30. 30 divided by 3 is 10. 10 divided by 2 is 5, and 5 divided by 5 is 1. So the divisors or factors of 36 are 3, 2, 3, 2, and for 90 we have 3, 3, 2, 5. Next we plot all these factors on our Venn diagram. So for our left circle we plot all the factors of 36, and on the right we plot all the factors of 90. Now for the middle part, this is where we find the area of intersection, or the area for the common factors. After plotting, we found out that the common factors of 36 and 90 are 3, 3, and 2, and by multiplying 3, 3, and 2 we get 18. Hence the GCF of 36 and 90 is 18. Our third method is the Euphydia algorithm, and this method is very useful if we are finding the GCF of large numbers. Now this method states that if we have two numbers x and y, and x is greater than y, the quotient of x and y is an integer q with a remainder r. And this further states that the GCF of x and y is also equal to the GCF of y and r. Now to illustrate this, we have an example. So we need to find the GCF of 90 and 72. First we divide 90 by 72. We get a quotient of 1 and a remainder of 18. Next we divide 72 by 18, and this gives us a quotient of 4. Now there's no more remainder at this point, so we stop and we look at the final divisor, and that is 18. Therefore the GCF of 90 and 72 is 18. Now to better understand Euclidean algorithm, we have here our second example. Say we need to find the GCF of 896 and 427. First we divide 896 by 427, and that gives us a quotient of 2 and a remainder of 42. Next we divide 427 by 42, that gives us 10 with a remainder of 7. Finally we divide 42 by 7, and that gives us 6 without any remainder. So we stop at this point and we check our last divisor. Our last divisor is 7, therefore the GCF of 896 and 427 is 7. Finally, our last method is a shortcut that can be used to find the GCF of 3 or more numbers. This can also be used by those who will be taking board examinations and other related math tests. Now, this method requires familiarity with the divisibility rules. So here we have an example. We need to find the GCF of 8, 12, and 28. First, we need to check the smallest among the 3 numbers, and that is 8. Next, we check the divisibility of the other 2 numbers by 8. Now, 12 and 28 are not divisible by 8. So we proceed to factoring, or to the factors of 8. The factors of 8 are 4 and 2, and 4 is greater than 2, so we check the divisibility of the other 2 numbers by 4. 12 is divisible by 4, and 28 is also divisible by 4. Hence, the GCF of 8, 12, and 28 is 4. Another example under this shortcut. Here we need to find the GCF of 16, 64, and 88. Now the smallest among these 3 numbers is 16. So we check the divisibility of the other 2 numbers by 16. 64 is divisible by 16. However, 88 is not. So we proceed to the factors of 16, and these are 8 and 2, and also 4 and 4. The greatest among these factors is 8. So we check the divisibility of 64 and 88 by 8. 64 is divisible by 8, and 88 is also divisible by 8. So the GCF of 16, 64, and 88 is 8.
Thank you for watching this video. I hope that you learned something. If you did, please share this with your friends. Also, please consider subscribing to this channel. Until then, God bless you.